Hello everyone, welcome back to the channel. In the previous series of videos, we have seen details about artificial neural networks, how an artificial neural network works, and what are the types of codes which we can use to develop an artificial neural network. If you have not yet watched those videos and you are interested to know about what an artificial neural network is, you can check out the videos whose links are in the description. If you recall, in the previous videos, we have discussed about how we can improve the accuracy of the prediction models. One of the method which we can use is normalization. So let's start with what is normalization, what are the different types of normalization, and discuss about a simple method and write a code for it so that you can do normalization of large lengths of data easily. Let's begin with the definition of a normalization. What does normalization mean? Normalization generally has wide range of definitions based on the domain in which it is used and based on the function which is doing. So let's talk about general terms. So in general terms, normalization means adjusting of the values to a common scale. We will be discussing about what this definition means and also discuss about the code in few minutes. So this is the basic definition. You are trying to adjust the measured data or whatever the data you have into a common scale for easier analysis. So what are the various methods which you can follow to do this normalization? So if we see, there are basically 6 types of normalizations which you can find uh, in an easier terms. There may be more number, but we will be seeing what are the 6 things which we can understand easily, and also write a code for one of the normalization method. So the 6 methods are minimum maximum feature scaling, standard score, student's t statistic, studentized residual, standardized moment, and coefficient of variation. So discussing everything in detail will take a bit of time. So in this video, we'll be discussing about the first type of normalization, and in the further series of videos, we'll be discussing each different method and write a code for a easier normalization procedure. So let's see what is minimax feature scaling with directly coming to the formula of the method. So if you see the formula here, this is the basic formula which you can use for minimax scaling. And if you see here, x bar represents the normalized data output which we get or which we want, and x is the input variable. It might have n number of rows and n number of columns, it does not matter. So minimum of x gives you the minimum value of the whole time series of variable x. The same with maximum. So the general formula is, you take the first element, for example first row first column value of x, and subtract it with the minimum value of the whole time series to the ratio of the value of maximum minus minimum. So when you use this formula, the result you get is in the range of 0 to 1. Why do we need to convert it to 0 to 1? Let's see another example and try to understand it. So if you see here, you see there are rainfall data and discharge data. Let's assume you are developing a rainfall runoff model and you want to convert rainfall to discharge. So if you see, rainfall has wide range of values from 0, 0.2, 1, 7, 2, 10, etc. etc. Whereas discharge, if you see 14, 18, 14, 12, 25, 30, let's just plot it to see what are the range of values. We plot the values, we can see that the rainfall data is from 0 to almost 300 mm. That is the range of rainfall. So let's just name it as rainfall. and let's take it to the top, put it here, and also do the same thing for discharge. So now if you see, rainfall is in the range of 0 to 3000, whereas discharge is in the range of, generally it never becomes 0, but the lower limit, let's say it's 0 to almost 2200. So now when you are giving this data only rainfall as input and asking discharge as output, you can see the neural network should try to understand how we are trying to change the data from 300 to 2200, let's assume, on a single day. So when it is trying to convert this, you can see there are wide range of values here, from minimum of 0 to a maximum of 300, whereas similarly here you have a minimum of some, let's assume, 100 to 2200. So trying to get a relationship between this varying precipitation values and this varying discharge values is not easy, because maybe uh, you have some weight of 10 at one point, but in the other uh, section you have a weight of 0.1. So if you see, there are wide range of variable weights which it has to assign to give a good output. So giving this is not very easy, although however complex a neural network is, it's not very easy to understand to it. So in order to make it easier and get a better result, we use normalization. So how do you know normalization? You remember, this is the formula to convert all these values, all these 50, 54, 60 and so on, to zeros and one, both the rainfall and discharge. So these datas are converted to 0 to 1s to develop a good model. So let's go to Matlab and see how we can write this code and how we can normalize the data. So if you see here, I've already prepared a code, just a simple 3 lines, to understand how normalization is done. So if we come to the first line of the code, if you see, I'm creating a function. What does a function do? Instead of running the code line by line every time you want to normalize, we just created a function, thereby we can call this sentence in command window, and it goes, this sentence, with the amount of data we give, it goes into the code and runs everything and give us the output which we want. So that is why we recreated a function here. So when we see this line, let's start. What does A mean? If you remember, I said it is a minimum maximum feature scaling. So here we are finding what are the minimum and maximum values first. So A represents the minimum value of the whole data, B represents the maximum value of the whole data, and normal data is the name of the file of the output which I want it to give it to me. So whatever the variables which you give in the square brackets are the ones which will be saved in the workspace. So we have given all these three. Then here, if you remember again from our previous code, this is the name of the function which I created. So you have to save your file in the same name for it to work properly. And the next thing is data. These are in the round brackets. If you see, whatever you are giving, these are the input data which we are giving. So you should see that the name of the input variable is same all over the code. So this is the input data which I have just named data, and you will be assigning the name whatever is in your workspace. So this is the name of the data which I have to give as input. And n, what does n mean? You might be having n number of columns of variables. For example, in this example we have two variables, which is rainfall and discharge. So what I am doing is I'm telling the code I want these number of variables to be analyzed. So that is the value of n. That is the first sentence, which explains about what is the minimum and maximum. So when we come to the second sentence, we can see that we have written a for loop. It starts here and ends here. Why did we write it? As I've mentioned earlier, we have two variables here, rainfall and discharge, which we want to normalize. You might be having 10, 100 or more based upon the type of analysis you want. So what I'm doing here is I'm saying I have these number of columns. I represents the number of columns in which it should save the result and the column number. So if you see here, I is equal to 1 is to n. What does it represent? So this is the number of columns which it will save, and this is the number of columns which I want it to analyze. Let's assume if we have only one column. So if I give n value as 1, I will be 1. So it will save in the first column. Whatever the results which we get are saved in first column. If you have two columns, it will save the results on first column and also the results of second column. I'll be showing it in an example. So that is the reason why we have written the for loop. So the final sentence, what does this sentence mean? As mentioned earlier, normal data is the output value which I wanted to save, and how many columns I want to save depends on the number of columns in our data. So if you remember the formula of the minimax feature scaling, this is input value minus minimum by maximum minus minimum. So the same is written here, input value minus minimum by maximum minus minimum value. So what are we doing here? We are asking it to subtract each variable. So each variable in the data is subtracted with minimum and divided by the maximum minus minimum. So this is the code which we can use to normalize the data. So let's start with an example. So the first main thing you should see is you should be in the same path as where this code is. My code is not in this path, so I can just press here and go to my codes and let it come. So if you see here, normalization is here, so I can run this code. So for this analysis, I've already shown you the data, so I'll create a name, let's say file, and I will paste the same example data which I've shown so that you'll see the distinction between the rainfall and discharge. If you see, you can copy and paste it and go here and paste the whole data. You see there are two columns, one is rainfall and one is discharge. So let's begin with the code. As I told you, you don't need to run each line. You can copy variables from here to here and save it here. So if you go here and write what is the name, file. First, we will see how it functions with one column. So if I give one column, what will happen? So we press it, enter, you can see has already shown you A represents the minimum value which is 0, the maximum is 292. The reason for saving these files you'll be understanding in the further explanation. So if we see the normal data, you can see, let's plot it, click here, go to plots and plot it. See, the range is between 0 to 1. Here you can see that it is normalized correctly. So let's go back and try to give it for both sections. So we'll see how this code functions and how it saves if you have two columns. As I mentioned in previous videos, if you go to the command window and press your upper arrow key, you can see all the codes which you have used. So we'll go to the code which we used to run it, then change the value from 1 to 2. So if we change it, we can see after pressing enter, you can see that two values are saved here. So both the minimum values are 0 and the maximum are 292 and 5134, sorry, 2265 in discharge and rainfall. So if we see the results, you can see that this is the precipitation which we have observed. So let's try to plot the discharge and see. You can see that the values are in the range of 0 to 1. So both the values are successfully normalized. So that is how you can do a normalization. So let's take this scenario. You have completed normalization, you have run the code, you got a good result of simulation, etc. etc. But is that normalized value the correct representation of discharge? Can you show the result in zeros and ones? Because that does not depict the exact representation. So you need to bring back the data into its original form. So how can you change it to its original form? This is called denormalization of the data. It's like you normalized it using some constants, you brought it to a common scale. As I mentioned, that is the definition. Now you need to bring it back to its original scale. How can you do it? So we can do it using a code again based on the variables of A, which is the minimum of the data, and B, which is the maximum of the data. So that is the reason why we are saving this value so that we can denormalize the data back to its original state. So now let's see the code uh, which we can use for denormalizing the data. So if you see here, I've already written a function again for easier application as denormal data. It represents the denormalized data. The name is same as denormalization. What are the inputs I'm asking for its denormalization? So the main input which we want is the data in a normalized form. So whatever the result, let's assume this is the simulated result which we want it to bring back to its original state. So this is the data which we need to give as an input to the code which I have written here, and represents the number of columns which we want to analyze. A represents the minimum value and B represents the maximum value. So that is the main reason I have mentioned we saved these two. So again, it's the same for loop function. It can denormalize n number of columns if you have n number of minimum and maximum values. So how did we approach to this formula? If you remember the previous formula which we have used, so this is for normalizing the data. How do you get the original value? So this is the original value. Simple thing which you can do is you can push the denominator to this side, which becomes multiplication into normalized value with addition of minimum. If you take this one here, so only x remains in the right hand side and everything goes to the left hand side. So that is the code which we have, which you are seeing here is input into maximum minus minimum plus minimum. So this is the simple code which we can use to denormalize. Again, remember you should be in the same path to run the code. So now if we copy paste this into our command window and give the name as normal data as it is saved here, and let's give 2 because we have two columns. A and B are saved as A and B. So let's just press enter and you can see that the data has been changed and it is saved. So if you see here, let's compare with the original data which is file. So the first value is 50. If you go to the denormalized, it is 50 again. Second value is 54, 60, 52, 39. 54, 60, 52, 39. You see all the data has been brought back to its original form. So in this way, you can use both normalization to get the data into 0 and 1 format and run the code of any model which you want to develop, any statistical or data driven model, and get a result, and then bring back the code using this denormalization function to its original form to represent it correctly. So this is how you can do denormalization in minimax feature scaling. In the next video, we will be discussing about other forms of normalization, which I've mentioned in a video earlier, and how we can write a code for them for their easier explanation. So if you like the video and you understand it, how you can do it, please like it and subscribe, and also share it with your friends whom you think it can be of some use for.